Okay, in this lesson we're going to be looking at functions. Our essential question, how can we model relationships between quantities? Our I can statements, I can define and explain in words what a function is and how it relates to input-output tables. I can explain how the graph of a function relates to its set of ordered pairs. Some terms that we want to look at right off the bat are relation, domain, and range. A relation is any set of ordered pairs. So I could give you a set of 3 ordered pairs. 0, 1, 2, 4, and 6, negative 5. So that is a set of ordered pairs, 1, 2, 3 different ordered pairs. That's called a relation. The domain are going to be those input values, or what we've looked at as independent values, or the x values. So if we look at this set of ordered pairs, the domain values are going to be all of those x values. So in this particular situation, it's going to be the 0, the 2, and the 6. The range is the opposite side of that. Those are going to be your output values, what we've called the dependent values. Those are going to be the y values. So in our initial relation, now let's look at all these y values and list all of our range numbers. We've got 1, 4, and negative 5. So it's just that easy. When you're given a set of ordered pairs, tell me what your domain or your x values are and what your range or your y values. So let's look at using what we just learned as far as some new terms and complete a table of values. We have done this, believe it or not. When you were asked to graph a linear function, the first method we used was making a table of values. We picked our own x values, which are called those independents. We talked about those. Well, now we're going to look at this as called an input number or a domain. So our domain numbers are negative 1, 0, and 1. So we're going to look for our range numbers by plugging the x value into the function to find out what the output number would be. So for instance, let's do the negative 1 in for x. Instead of y equals 3 times x, we're now going to do 3 times negative 1 minus 2. So that gives us negative 3 minus 2, which is a negative 5. So when our input number is a negative 1, we're going to input it so we get an output of negative 5. So that gives us an ordered pair. We've done that. So I'm going to leave this for you to finish, and then in the next example, I'm going to be looking for this in class. Finish these 3. Give me your 3 ordered pairs, your 3 new output or range numbers. Then, the second part of example 1, express that relation, those 3 ordered pairs that you get in your table, as a graph. So I want you to graph it on a coordinate plane so that you see that relation, that set of ordered pairs, written 2 different ways or expressed 2 different ways, in a table and in a coordinate plane graph. So I'll be looking for that in your notes when I check them tomorrow. The other term we want to look at is a function. This is a new term. It's a relationship in which every member of the domain is paired with exactly 1 member of the range. So let's look at an example of finding a function value. So we're going to look at this right here. We want to find the function value of f of 6. If our function rule is f of x equals 4x. So the function of x is equal to 4x. So what we're going to do is you want to look and see what's in those parentheses. We're putting a 6 in place of the x. If you notice, we start out in the function rule with x in the parentheses. Well, we want to find out what the value would be if 6 was put in place of that x. So if we now want to do f of 6, we're going to take that 6 and substitute it in for the x. So instead of 4 times x, we're now going to do 4 times 6. So the value for the function of 6 in this particular situation would be 24. That would be your final answer. So we found that function value. If f of 6 were involved, we'd be putting 6 in place of x. Let's do one more example. We're going to find the function value. Again, this is our function rule. Let me highlight this time. Our function rule, f of x is equal to 4x plus 7. So our function rule is 4x plus 7. Our input, which is the x, they're giving to us. They're asking us, what would f of negative 6 be? So you can almost treat this like it's in a table. Negative 6 is your input. You're going to put it in place of x, and you're going to get an output. That would be your function value. So in this case, they don't want you to do a whole table. They're just giving you a value that they want you to plug in. So we're going to put negative 6 in place of x. So now instead of 4 times x plus 7, we're going to do 4 times negative 6 plus 7. 4 times negative 6 gives us negative 24. Negative 24 plus 7 gives us negative 17. Okay? So the function of negative 6 is negative 17. So tomorrow we're going to look at some more examples, set this up as tables and graphs, and explore a little more.